So here's a graph in autograph, basic sine function. So what we'll do is we'll just play around with some of these values and see what happens. So at the moment you can see the blue curve here, the basic sine function. There's also another curve I've plotted, which is at the moment is the same. It's also y equals sine x is underneath this. But let's just change this to transform sine function and see what we get. Well, there are four transformations you need to be aware of. One is simply if you make the function negative in terms of the algebra. Now if you think about what's happening here, when I work out sine x, I'm getting some values. But if I just make it all negative, it's just going to negate those values. So if I was getting positive values before, I'll now get negative values. So when I graph that, you can see that, of course, where it was 0 before, it's still 0. Where it was negative 1, where it was 1, it's now negative 1. Where it was, for example, a half, it's now negative a half, and so on. So putting a negative sign in front just reflects it in the x-axis. What was positive becomes negative. What was negative becomes positive. There's the first transformation. The second one is that you need to be aware of is adjusting the amplitude. I'll just plot the basic sine function again. Now, once again, if we think about what we're getting here, once we've worked out sine x, we're getting y values. So if I multiply this by some number, my y values are going to, in this case, double. I'm multiplying everything by 2. So what was 1 has now become 2. What was negative 1 has now become negative 2, and so on. What was a half has now become 1. So all of my y values have doubled. So this, you can see this has affected the amplitude. The amplitude for the basic sine function is 1, but for y equals 2 sine x, the amplitude now is 2. You can see that it has not affected anything else. It hasn't affected the period, that's still 360. And the principal axis is still the same. There's still this symmetry around the x-axis. So the coefficient of sine x basically is the amplitude. Now let's have a look at the other parts. The next one you need to be aware of is a vertical translation. If I just add something on the end here, again, let's think about what's happening here. So I'm working out sine x, I get my y values, and then I add 1. So I'm basically adding 1 to all my sine values, all my y values. So that corresponds to a vertical shift. So where I got 0 before, I will now get 1. Where I had 1 before, I will now get 2. And so on. Where I had negative 1, I will get 0. So everything's being translated vertically upwards 1 unit. I'm adding 1 to my y values. So that has obviously affected the principal axis. The principal axis now is y equals 1. It's here. The amplitude hasn't changed. I'm still going 360 degrees before it starts to repeat itself. So the period is still the same, 360 degrees, and the amplitude has not changed either. It's still 1 unit in this case from the principal axis to the maximum, or it's still, if you prefer 2 units from the maximum to the minimum. So adding something on the end will graphically translate the graph vertically upwards, and it won't change anything else. The principal axis will increase as described there. If it's negative, of course, it just goes the other way. So if I make this minus 2, then everything's translated 2 units down. The principal axis here now is y equals negative 2. The period is still 360. The amplitude is still 1. And the fourth change, this is the harder one. So y equals sine 2x. So here I'm changing the coefficient of x before I take the sine. This is a little bit harder to understand because it kind of does the opposite of what you'd expect. So if we look at the graph here, you can see everything's become squashed up. So you might think that multiplying x by 2 would make everything stretch out along the x-axis. It actually has the opposite effect. you can see that the amplitude is the same, the principal axis is the same, but the period has changed. The period was 360. I had to go 360 before it started repeating itself, but now I have to go 180. So if I multiply x by 2, I'm actually halving the period. Just have a look at this algebraically. So we've looked at a few changes to the sine function. Either putting multiplying by a number at the front, okay, which just changes the amplitude. So basically A equals the amplitude. If this is 3, the amplitude's 3. If this is 10, the amplitude's 10. If it's 106.5, the amplitude's 106.5. Now B, I'll come to B in a moment. That's the harder one. C is a vertical translation. Of course, if C is negative, then it goes down. So this is basically you can think of it just as the principal axis. Okay, it's actually what y equals c is the principal axis, not c on itself, because it's the principal axis is a line, so it has an equation like this. Okay, now b is related to the period. Now, a common mistake is that students think that b is the period. Okay, so don't fall into that trap. It's related to the period, and it's related to the period in this way. B is the sorry, let me change the way I'm thinking about this. So that the period is 360 divided by B. So we saw from the example before here, if B is 2, then the period is 180. So in this case, we've got period is 360 divided by 2. B was 2 there, 180. Okay, and you can manipulate this equation. If you know what the period is, then this equation can be changed to B equals 360 divided by the period, and this will become more relevant when we look at modelling a little bit later on. Okay, so just to recap. Sine function of this form, the coefficient is the amplitude. What you're adding or subtracting graphically is a transformation. It's a translation vertically, and the principal axis is y equals whatever this value is. And b is related to the period. The period is 360 divided by b. Or you can rearrange this, multiplying both sides by b, divided by period. You get b equals 360 divided by the period.